Um, Good afternoon, good morning, good evening, whatever time of the day you are watching this video. You are welcome again. My name is Emmanuel, and I welcome you specially to this coaching class, and thank you for clicking this video to watch it. Either you are my student or you are just coming across my videos for the first time. I have a goal I wish to achieve this year, and that is to have as many as 250 students to pass their JAMB with a minimum of 250 marks in total. So if you are here, I believe you've clicked this video because you are one of those who are preparing for JAMB in 2025 and you have a desire to have a good score or to pass well. So I appreciate you and I salute your courage for taking steps to prepare yourself very well ahead of the challenge, and I wish you the best. So what I do is I have a coaching class where I have a special students who are committed. Yes, we have been together for quite some times now, though some have been joining along the way, but we have been doing so much training both in understanding patterns of JAMB question, understanding how we study to get it best, and training in recall. Sometimes you may study and when you get to exam hall, it will just be as if something just came into your memory and wiped out everything. Yeah, the anxiety can make you forget everything. Yes, so I've been training my student specifically in some key areas to make sure that when they get to the exam hall, there will be no fear. In fact, I love my students, especially those who are committed, and that's why I've created a special group for them. I want to give them enough time because they have shown commitment to learn, and I want to attend to them. So they have been taking big challenges. Yes. And I'm so proud of them. They have been facing questions, tough questions for that matter. If you are one of them and you are watching this video, I hear you. Well done. So please, let's continue. All right. So I want to make sure that you are well prepared for this year's JAMB so that you can get the best. I'm proud of them. Many of them, they are doing well. Yes, many of you, let me say, if you are watching and you are my student. However, if you are not my student and wish to join us, the room is still open for you. Meanwhile, in a very short time I'm going to close the group so that I will not allow more students to join again. I don't want a die-minute preparation. So if you are not joining now, don't bother to say in 1 week time I will come to join. Please and please, I urge you. I don't want fire brigade approach to matters. So I hope you get this very well. Thank you. If you wish to join, just drop in a comment section, I want to join your special coaching class. Then I'll find a way to add you. Thank you very much, and I wish you the best. Let's quickly look at the questions we have before us today. Yes, today's questions are from physics, and guess the topic, motion. Yes, and all today's questions are directed towards calculations. I deliberately did this because many students avoid calculation questions. Many coaches, many tutors don't want to enter calculations. Yes, they will just bring questions that are answer A, all those theoretical questions that doesn't have to do with any calculation. But I don't prepare my student like that. In fact, these days, we are going to do more of calculations to make sure that I've equipped them also on handling challenges that has to do with calculations. If I give you only questions that are theoretical, that you don't need calculations, I'm not helping you. You need calculation questions. By the way, my students, remember that we face challenge. We are challengers, so we challenge. Yes, that's what we are. So I'm happy and I'm proud to have you guys work with me this time around. And I tell you, if we continue like this, beyond JAMB, you are going to do well even in life. So thank you for picking interest in joining my class. For those that are with me already, if you wish to join, I say the room is still open, but don't come late. If you come late, I'm so sorry, I may not be able to add you to the coaching class. Yes, I remember yesterday I said um, today's challenge is going to be tough, right? Okay, I was just referring to the fact that we're going to look at calculations today, and here we are with some physics questions that I would like you to familiarize yourself with, because I have observed over the years there is no year JAMB doesn't ask question on motion. No year. I have observed over the years. So we are going to familiarize ourselves with them so that we'll be able to face them squarely when exam comes. All right. You know what? I have observed also that whereas JAM asks questions in calculations, most of their questions are, guess, very, very simple. You don't even need calculator because they use simple numbers, simple, it is just super simple. So I trust my student, they will do well. Yeah, I trust them. All right, so let's get right into today's deal. All right, so we have our first question here saying two cars moving in the same direction have speeds of 100 kilometers per hour and 130 kilometers per hour. What's the velocity of the faster car as measured by an observer in the slower car? Now, if you look at this question carefully, sincerely, if you are not logical, because some of these things might not even be taught in secondary school. The question has to do with logic and it also has a formula. But if you are logical, you can even answer it without a formula. But if you are not logical, you may be thinking, which formula now will I use? You know, that kind of thing. All right, so how do we answer this question? Just think about it. Two cars moving, one at 100 kilometers per hour, one at 30 kilometers per hour, and 130 kilometers per hour. Let's assume you are in the car that is moving at 130 kilometers per hour. How do you calculate the speed? Let's assume you are the observer, you are in the faster car. So, with reference to you now, how do we measure the speed of the slower car from your own position as an observer? Do you get what I'm trying to say? So it's very simple and logical. This one is moving at 30 kilometers per second. 100 kilometers per second, and this one is moving at 130. So we are talking about relative speed at this point in time, or relative velocity. So a relative velocity have a formula, and the formula is relative velocity is equal to the speed of the faster car minus the speed of the slower car. So if we want to measure the velocity, let me be using speed. If we want to measure speed, not even speed because it's velocity that we're asked to calculate. Let me not confuse because the two are different, quite all right. The two are different. So if you want to measure the velocity relative to your own position in the faster car, it is going to be the speed of the faster car minus the speed of the slower car. So, and that will be 130 kilometers per hour minus 100 kilometers per hour, and that will give us 30 kilometers per hour. So I've already solved the question here. I believe you can see the solution to the question. So slower car the speed for the slower car is 100 kilometers per hour. The speed of the faster car is 130 kilometers per hour. So velocity relative is going to be the velocity of the faster car minus the velocity of the slower car, which is 130 minus 100, and the final answer is 30 kilometers. Thus, the correct answer is D. Let's go to the next question. The next question says a car moves with an initial velocity of 25 meters per second and reaches the velocity of 45 meters per second In 10 seconds, what's the acceleration of the car? Do you see this question now? We are asked acceleration. Now, let me advise you at this point to memorize equations of motion. There are about 4 equations of motion. Please, I'll mention some here. Go and write them out and master them. Very, very important. Very important. Very important. Please and please, I urge you, go and master them. So that any question, all the questions under motion, linear motion, motion under gravity, you can answer them using those equations once you get them. So please, I beg you, go and master them. Thank you. So look at this question now. We are given initial velocity, we are given final velocity, and we are given time. We are asked to calculate acceleration. So we have a formula we use in calculating acceleration, and the formula is A, which is acceleration, is equal to final velocity minus initial velocity all over time. I think I've written it here. Yes, it's here. So look at this formula, please, and please master it. And note that you can use this same formula to calculate time if you are given acceleration, initial, and final velocity. I hope you know how to do that. What you need to do is to cross multiply and make t the subject of formula, which is time, and substitute, and that's it. So it is very simple. This year's own may come like that. If this explanation is not clear, just pause the video here, drop your question in the comment section. I will come and attend to them later. And if you have not subscribed to my channel yet, okay, my students, I know many of you have subscribed, but if you have not subscribed, just do that now before you forget. Do that now, like also, so that many others will also see this. Please subscribe and like. Thank you. So we have the formula to address this question here, and the formula is A is equal to V minus U all over T. Now observe that all the parameters we need are given to us. The final velocity, which is V, is said to be 45, the initial velocity 25 divided by our time. Time given is 10 seconds. So by the time you say 45 minus 25, we are going to have 20. 20 divided by 10, that will give us 2 meters per second square. Therefore, the correct answer is D. Alright, so we move to the next question. Yep, the next question came from JAMB 2011. That's question 6. And the question says, an object of mass 2 kg moves with a velocity of 10 meters per second round a cycle of radius 4 meters. Calculate the centripetal force on the object. Yes, when an object moves round an object or round a center, around a cycle, there is a force that it has while in that motion, and that force around a fixed point is what is known as the centripetal force. So there is a formula for calculating centripetal force, and the formula is F is equal to M, that's mass, V square, that's the velocity, all over R. I hope you write out these formulas that I'm saying, so that you write centripetal force, then you open bracket, write the formula inside, so that when you come for revision, you will remember. It will help you to memorize the formula for centripetal force. So we are given all the parameters also here. We are calculating force. So what we need to do is to substitute the values we have. We have mass as 2 kg. We have velocity as 10 meters per second, and we have radius as 10. So look at the substitution that I did here. Force is equal to 2 times 10 square all over 4. Just substitution. So 10 square is 100. So we have 200 divided by 4. If you say 200 divided by 4, the answer will be what? 50. So the correct answer is 50 Newton, which is D. 50 Newton. Please write out these formulas as I'm saying. At a point you can pause, write it out so that you will memorize these formulas. I want you to master them. You need them. Very important. And also note, if you are given the centripetal force, you are given the mass, you are given the velocity, you can calculate the radius. Yes, just substitute to make R the subject of formula. If you don't know mathematics, a little of mathematics, physics will not be that easier for you. If you don't know it at this point in time, it is not late though, you can still learn it. But specifically, one favor you will do me is to master how to change the subject of formula, how to make any parameter the subject of formula. Very important. Most times this has to do with cross multiplication, dividing both sides by this, or rearranging, taking this to the other side, taking this to the other side. And that's simple. So if I were you, once I see a question, they are talking about centripetal force, the first thing I will do is to write this formula down. I will now observe what is missing. Is it mass that is missing? Is it velocity that is missing? Is it radius that is missing? Or force? So if it is radius that is missing, what do? I should try and make R the subject of formula. Whatever that R is equal to, I will just substitute the values, calculate, and that's all. So you see how simple and easy it is. It's something you can do. Let's look at the next question. If you have not subscribed, don't forget, do it now before you forget, so that I've posted several videos on this channel and I'm still in the process of posting, and every day I try to see how I improve the way I deliver so that you will get it better. So don't just watch this, watch more. Yes, you will learn a lot. Thank you. And most times I try to put some things beyond just normal learning book. I share some tricks, some tips that will help you. Thank you very much. Let's go to the next question. The next question is question 7 in JAMB 2011. And the question says, if it takes an object 3 seconds to fall freely to the ground from a certain height, what's the distance covered by the object? So do you now see this? This is now talking about height. It's not talking about moving on a normal ground. It's talking about height. So the acceleration due to gravity is always constant when an object is falling from height. Do you get what I'm trying to say? Provided that there is no air resistance, the object falls freely, and that's why they say it falls freely from a certain height. Alright, so we are asked to calculate the distance now. So I've already stated earlier that we have 4 equations of motion. Try and have them written. I've already stated one where we calculated acceleration. I'm still going to mention like 2 or more in this video. Please write them out and master them. Please and please. Do I need to remind you later? No. You may pause the video now. Write this out. I hope you've heard me. Alright, so we are calculating distance here. So there is a formula we are going to use. Now let's look at what is given. Time is given, acceleration due to gravity is given, initial velocity is given. Do you observe that though it has not been categorically mentioned that the initial velocity is 0, but you should know. You know why? This object was at rest before falling. That's it. So if they say a car starts at rest, you should know the initial velocity now. It was at rest, so the initial velocity is always 0. Or if an object starts falling from a height, it was first at an initial velocity of 0 before it starts moving. Or they will say a car come to rest, or a train come to rest, or a moving object come to rest. What will be the final velocity there? Not initial this time around now. It was in motion and it come to rest. So the final velocity will be 0. Yes. So please, they will not mention this in question. They will never mention it. You have to know this also. Don't worry. Mental drills are coming. I'll catch my students. I'll catch them. I always say, listen to my explanation very well. I'll catch you. Alright. Thank you. So this is the equation we are going to use, which is also the equation of motion, that says S stands for distance, is equal to U. U is the initial velocity times T. T is the time, plus half G, we know our G now, gravitational force now, times T again, square, which is the same thing as the time we earlier mentioned. Alright, let's substitute and see what we have. What do we have? Distance is equal to 0. Because initial velocity is 0, I said the object was first at rest at a height before it started falling. So the initial velocity when it was at rest before it started falling is what? 0. So our time is given as 3 seconds. So we substitute 3 for t, t for 3, then plus half, our g is 10 multiplied by t square. So 0 times 3 is 0 down there, plus our half times 10 times 9. Then we have 90 over 2. And the correct answer is 45. It's 45 meters. 45 meters. So that's the height, which is D. I hope this is clear. Alright, so let's look at the next question. The next question says, calculate the total distance covered by a train. Calculate the total distance covered by a train before coming to rest. We are still calculating distance covered by a train before coming to rest, which means it was in motion before it comes to rest. So the final velocity is already 0 from here. So this is how they will tell you your final velocity. They will say either at rest and it start moving, or they will tell you it comes to rest. So it comes to rest before coming to rest if its initial speed. So you now say initial speed is given as 30 meters per second with a constant retardation. Now, what is retardation? Retardation is the opposite of acceleration. While acceleration is positive, retardation is negative. That comes as a result of reducing speed. Yes. So please note that. So let's go and see the formula we are going to use. Is still an equation of motion we are going to apply. We have 30 meters given as initial speed. We have final velocity as 0. So you see, I put there in brackets, it comes to rest. All right. To smart students, they've already captured that, and they will never allow JAMB to they will never allow JAMB to make them fail that question because they've already mastered it. So the equation to use is v square is equal to u square plus 2as. Yes. Now observe what we are going to do here. How do we know that this formula is appropriate? We have used one earlier that has to do with s ut plus half gt square. Yes. Why can't we use it here? The reason is because in the previous problem or question, time is given. Do you observe that there is no time here? Fine. So this thing is, you just need to use your brain. You need to master these equations. So once you write equations, look at the one that you have all parameters given. Yes, that's the one that will be appropriate. So whereas this one is asking us for distance, the previous one is also asking us for distance. We cannot apply the previous one here because time is not given. So time is not given, distance is not given. So if we decide to apply the previous one, there is problem because we will have two unknown and we cannot make any calculation with these two unknowns. in one equation. We only have to have one unknown. So that's why this equation is the best for us to apply here. I hope someone is getting what I'm saying. Alright, so how do we go about it? Now observe here that distance, which is s, is not our subject of formula. So look at how this question is solved till s becomes the subject of formula. Alright, so substituting, our final velocity is 0 because it came to rest. Is equal to our initial velocity is 30 meters per second, which is substituted there for u square, 30 square, plus we have 2as, 2. That's the 2 in the formula. A, that's our retardation now. Retardation. Now, if we were calculating for acceleration, we still use that A for acceleration. I said acceleration and retardation are opposites. Acceleration and retardation are opposite. Acceleration is A, retardation is minus A. So that's why the formula is the same. What you need to do is that by the time you come to put the value of retardation, just put minus to it. Simple. Alright, so S, we don't know S, so we still write it the way it is. So by the time you open bracket, 30 square will give you 900. 2 times minus 0.1 will give you minus 0.2. S is unknown, so it still goes without 0.2. Do you see what we have now? So rearranging, we take minus 0.2s to the other side of the equation. It will become 0 plus now. You know when a negative value crosses the equality sign, it turns to plus. Yes, this is basic mathematics. You know that, I believe. So, we have 0 plus 0.2s is equal to 900. So if we say 0 plus 0.2s, what do we have? We are still going to have 0.2s because we are just adding 0 to it, and 0 is not adding anything, which is equal to 900. So by the time we divide both sides by 0.2, what do we have? We are going to have 4,500 meters, and that's the distance. I hope this is clear. Alright, so let's look at the last question. The last question says, a car starts from rest and moves with uniform acceleration of 30 meters per second square for 20 seconds. Calculate the distance covered at the end of the motion. Do you also observe we are still under distance? Yes. So by this time now, you can guess the formula we are going to use. Can you? Alright, let's look at the parameters given before you guess. Yes. Acceleration A is given. Time T is given. Only. And we are asked to calculate distance. Yes, can you guess? And the car starts from rest, so something also is given. What's that? Initial velocity, correct. Alright, thank you. So, we have initial velocity, we have acceleration, and we have time. So which formula do you think we apply? Yes, we are asked to calculate distance, remember. S, yes, equal to, yes, ut, yes, plus, yes, half, plus. Alright, half 80 squared. So that's the one we are going to apply. We are not going to apply g here because there's no movement from height. Note that the difference between the two is that when you have an object from height falling, you use g instead of a. Note that acceleration due to gravity and normal acceleration, all of them are accelerations. But acceleration due to gravity is always constant, unlike the normal acceleration by a moving object in a linear motion on the ground. I hope this explanation is clear. If it is not clear, arrange your question very carefully, package it in a way I can easily understand it, and drop it in a comment section. Yes. By the way, I need your feedback after you finish watching this video. Tell me, I want to know, was it hard? How was my explanation? Is it clear? Do you understand anything at all from all my explanation? Let me know how I can improve. I'm here for you. I'm here to make you understand. So I need feedback. Anybody that watched, so I'm watching I will check the number of persons that watched and the number of comments I have in the comment section. Thank you. So let's go on. I've already announced the formula we are going to add, we are going to use. So that's it. S is equal to ut plus half at square. So we have our u, which is initial velocity, as 0, times time is given as 20 seconds, plus half at square. So our a is given as 30 meters per second square, and we have our t again, which is the same thing as the first t on the that is close to 0, then square. So working this out, 20 times 0 is 0, then we have 30, we have 20 square is 400. So we have it there. So by the time you multiply, you are going to have 15 times 400, because half of 30 is 15. So 15 times 400, this will give us 6,000 meters. Change it to kilometers. How many meters make 1 kilometer? Conversion. 1,000 meters make 1 kilometer. Kilo always means 1,000. This is how I used to master things so very easily. You see, I'm giving you one tip now. All right, let me tell you something. Kilo means 1,000. So if they say kilometer, which means 1,000 meters. So 1 kilometer is equal to 1,000 meters now. Kilogram. How many grams? 1,000 grams. That's it. Kilowatt. How many watts? 1,000 watts. Do you get it now? So this is how I master things. All this micro, liter, I know how I master my things. Milli, I will not tell you this one. I'm giving you all my study tips. Yes. So the only thing is, most times if you know the unit, you will be able to convert easily. It's just as simple as that. Alright, I will end this video here. Before you go, subscribe. I want to reach more students, as many as possible. I want to reach them. Please subscribe. As you subscribe, my video YouTube will make it go more, because I need 250 candidates that I will train, and I will need 250 that will score 250 and above in JAMB. So I still have, I think in the group WhatsApp group there, we have 100 and something, which means because I need like 400 students or so. So please, the only help you can do for me, for devoting my time to explain these things, is to subscribe, like, and I want to hear your feedback about this video. As you reach this end, just write your feedback. How do you wish I should do it? I should have done it. Do you understand? Was it clear? Is there anything you can suggest? Just write anything concerning the video. Thank you so much. God bless you. We meet in the next class. Click the notification button so that anytime I upload a new video, YouTube will alert you and say, yes, Mr. Emmanuel have posted a new video. Thank you everyone, and God bless.